Hello, welcome to the YouTube channel of Matha. So today we are going to continue with the solution of Littoral Mock we started in the previous video. So this video is going to be part 2, ranging from question 12 to question 24. Without wasting any time, let us go directly to the first question. So this is question 13 of the paper we are working on it. So the question reads: the sum of the series 1 plus 2x plus 4x squared plus 8x cubed plus dot dot for negative a half less than x less than half is. So we need to find the sum of this series for that range of value of x. So let us look at the solution. We're having this series, but if you look at it very well, you're going to see that it is the same thing as sum from 0 to infinity of 2 to the x to the power of 2 to the x to the power r. So you're having, if you do, you are going to have the exactly the same series as given above. If you compare it to a geometric progression, you are seeing that we are having the first term to be 1 and the common ratio to be 2x. So the sum to infinity is a, that is the common, that is the first term 1 all over 1 minus the common ratio 2x. So you're having that sum to infinity. This answer C. That's all for this question. Moving to the question 14. Having, it says let P and Q be two statements. The inverse of the statement P implies Q is, or that is just a direct question. You're having this statement, the inverse is just not P implies not Q. The answer is C. Question 15, it says given the matrix 2 1 negative 1 3 4 5 1 negative 2 6, then the cofactor of 3 is, so we need to find the cofactor of 3 in that matrix. Having the matrix, the cofactor of 3 is the minor. If you take the minor, that is, you remove all the elements on this row and all the elements on this column, you are going to be left with 1 negative 1 negative 2 6 1 negative 1 negative 2 6. Here you take the determinant of it, and then the position here of 3 is at the negative position, because you're having positive negative positive negative positive negative positive negative and positive. So you see that 3 is at the negative position, so the cofactor is going to be multiplied with it. So we are going to multiply the minor with the negative. That's why you're having this negative in front here. The answer negative 4, which is A. Question number 16. It says the transformation of a curve y is equals f of x through 3 units along the y-axis is represented by. No, they said through 3 units, so it's a positive 3 units. It's not negative 3 units. So we are having y is equals to f of x. If you want to make it to go to 3 units, it means that y is changing from 3 units by positive 3 units. If it was from negative 3 units, we are going to have a negative here. That's why you're having y plus 3 is equals to f of x plus 3. Answer C. Question number 17. The relation R is defined on the set A equals 1 2 3 by R equals what you are seeing there. So the solution says we are having A, and then we are having this relation R. A is 1 2 3 and the relation R is, you read it as 1 relate 2, 1 relate 3 and 2 relate 3. We need to find if this relation is either equivalent relation, transitive relation, symmetric relation, or reflexive. So from here, you know that we are saying that 1 relates 2, yes. 2 relates 3, yes. 2 relates 3, yes. 1 relates 3, 1 relates 3. We are having that 1 relates 2, 2 relates 3, and 1 relates 3. So if you see this is a definition of a transitive relation, the answer is B. So the relation is transitive. So let us move to question 18. We are given the periodic function defined by f of x equals x squared minus 1 0 less than or equal for 0 less than or equals to x less than 2, x minus 2x for 2 less than or equals to x less than 5, where f of x equals to f of x plus 5. So you know that the function is periodic, so the period of the function here is just directly given to us, that is positive 5, since we know that f of x is equals to f of x plus 5. So you're having the period directly here. Let us move to the solution and see what it gives. You're having the function, so you're having f of x equals to f of x plus 5. So we are having f of negative 13 that we need to find it. So we need to express the negative 13 in terms of something that we are going to find. Let us find the something you are looking for. So having f of negative 30 is equal to f of 2 plus 5 into negative 3. 5 into negative 3 is 15, is negative 15. So if we add 2, you are just going to have negative 13, that is it. So f of negative 30 is the same thing as this, the same thing as f of 2. Since this is 5, see if we repeat this, you are going to have plus 5 plus 5 plus 5, that is 3 times. So just f of 2. So you're having f of negative 30 is equal to, since it is f of 2, you just replace the value of 2 in this second equation here, because f is 2 less than or equals to. So for the value of 2, we replace in this equation here. So you're having 8 minus 2 into 2, that's 4. The answer is A. Question number. So moving to question 19, which reads, given that f of x equals to 5 cos x minus pi on 4 and g of x is equal to 2 sin x minus pi on 4, the maximum value of g of x over 3 plus absolute value of x is. So here we need to find the absolute value of that expression given to us. Let us see what the solution will give us. We are having f of x is equal to 5 cos x minus pi on 4. But we know that negative 1 is less than or equal to cos x minus pi on 4 for every value of x. Yes, this inequality here holds for every value of x, because x is always in between negative 1 and 1. If you multiply both every side here of this inequality here with 5, you are going to have, in multiplying here with 5, you are going to have negative 5 less than or equal to 5 cos this, which is f of x. So 5 cos pi minus 5 on 4, that is f of x, less than or equal to 5. This implies absolute value of f of x is less than or equals to 5. Then you're having g of x is equal to this. If we do the same process with g of x, you're going to have negative 2 less than or equals to g of x less than or equals to 2. But we need to find the maximum value of this, we don't forget. So we're having negative 2, if you add 3 here in this inequality, you're going to have negative 2 less than or equals to 3 plus f of x less than or equals to 8. Taking the reciprocal is simply 1 over what is there. So we are going to get negative 1 over 2 less than or equals to 1 over 3 plus f of x less than or equals to 1 over 8. Note that it didn't, the side didn't change because of this negative sign here. There is a negative sign. If there was not a negative sign, this a half will have went here, and then this 1 over 8 will have come here. So we are having multiplying here with g of x, you are going to have just the maximum value of g of x is 2. So to multiply the maximum value, you are going to have minus 1 over 2 times 2, that is negative 1, less than or equals to g of x over 3 plus f of x less than or equals to 1 over 8 times 2, which is 1 over 4. So we see answer is A. We can conclude. Question number 20. The general solution of the equation 2 cos square theta minus 1 is equal to 0 is. Let us find the solution. So we are going to have this. That's the equation given to us. But we know that from here you can come out with cos theta is equal to plus or minus square root of 2 over 2. Yeah, but we need the general solution. We don't use the cast diagram here because we just need the general solution. I think you can use, just try to use and let me a comment below. If you get the same answer as we are going to get, just leave us a comment below if you use the cast method. Yeah, here you are going to have alpha is equal to cos inverse of root 2 on 2, that is equal to pi on 4. Forget about the sign because we just need this, the principal value. That's how we also call this particular alpha, the principal value. So we are going to have, from here we can have the general solution of cos theta, that is theta is equal to 2 pi n plus or minus alpha. This plus or minus is already in the formula. It is not this plus or minus we have used, but the plus or minus that is in the general formula. So don't get confused while solving similar questions. So this is the principal value. This is alpha. I think for those of you who have formula booklets, you can get this formula inside. Yes. So your having answer is A. Moving to the next question, which is question 21. So we're having limit as x tends towards infinity of 1 minus cos x all over sine square x is equals to, so you need to find this limit. We have limit at x tends towards 0 of 1 minus cos x all over sine square x. If you substitute 0 here, having 1 minus cos 0, which is 1 minus 1, so which is 0, all over sine square x, that is 0 to the power 2, which is 0. So having 0 all over 0, this is an indeterminate form, so we cannot find its limit by direct substitution, so we use L'Hopital's rule. If now we are having this, leaving L'Hopital's rule, we differentiate the numerator and then we differentiate the denominator. Differentiate the numerator, if you differentiate 1 with respect to x, you are going to have 0. If you differentiate cos x with respect to x, you are going to have negative sine x. The negative sine x is going to multiply with this negative sign in front here, leading to sine x. But if you also differentiate the denominator, if you differentiate the function to the power, you first write the power down, that's 2. You differentiate the function, that's cos x, and then you rewrite the function and reducing 1 from the power, that's sine x to the power 2 minus 1, just 1, that is sine x. That's just simple. So we are having limit as x tends to 0 of sine x all over 2 cos x sine x is equal to limit at x tends to 0, sine x is just going to go, they're just going to cancel each other. You're having 1 over 2 cos x. But if you just from here you just use direct substitution, you're having 1 over 2 cos x as 1 over 2, that's just 1 over 2. From there you can conclude answer is B. Remember there are many ways to solve this, but take the shortest way because we are in paper 1. Moving to the next question. Question 22. I mean, if x is equal to theta plus sine theta and y is equal to cos theta, then dy dx is equal to, we need to find dy dx. Yeah, I know that that's the equation given to us, x is equal to theta plus sine theta and y is equal to cos theta. It's just parametric equation. You know that dx d theta is equal to 1 plus cos theta, and then dy d theta is equal to negative sine theta. Dy dx is equal to dy on the theta times the theta on the x. This is just the exchange rule for those who have noticed it. Here is the exchange rule. So here dy dx, dy d theta is negative sine theta. The theta on the x is 1 all over the x d theta. That's 1 plus cos theta. That's 1 all over 1 plus cos theta. So we see that the answer here is negative sine theta on 1 plus cos theta. Answer A. Moving to question 23. That's the equation of the normal to the curve y is equal to x squared plus 1 over x at the point where x is equal to 1 is equation of normal. Let us go and see how funny you get the answer. You're having y is equal to x squared plus 1 over x. The derivative, that's dy dx is equal to 2x minus 2x, yes, minus this is x to the power negative 1. We bring the power down, that is negative 1, x to the power negative 1 minus 1, that's x to the power negative 2. We bring 1 all over x squared. So at x equals to 1, m, that's the gradient, the derivative here is equal to, if you put 1, you are just going to have 2 minus 1, that is 1. And then y is equal to, if you put 1 here, you are going to have 1 plus 1, which is 2. But the equation of normal is given by y minus y1 is equal to negative 1 over m into x minus x1. y1 and x1 represent the respective points, the respective value of x and y. So having y1 which is 2 and x1 which is 1, y minus 2 is equal to negative 1 into x minus 1. From here you just simple arithmetic, and then you come out with the equation of the normal. Answer D. Moving to the last question of this part of the video, we are having question 24. It says integral from 1 to 4 of x all over 1 plus x squared dx is, we need to find this integral. Well, how can we find it? If we multiply the numerator here by 2, we are in 1 all over 2 integral of 1 to 4 of 2x all over 1 plus x squared. This half here can enter, so you have not changed anything, because this 2 is still going to go here. We have not changed anything. If you just look at the denominator where you're having 2x, if you differentiate the denominator, you're having 2x. So the 2x on the denominator is the same thing as the one on the numerator, so you can integrate this by recognition. So doing that, you are just going to have the half, which is this one outside the ln of the denominator from 1 to 4. Then just substitute the values and you are going to get your answer to be C. Okay, that's all for this video. Thank you for watched. If you went to the end, please, and you like the video, don't forget to hit the like and subscribe button. Leave a comment if you liked it, and please share the video with those who are interested in seeing more. Stay tuned for part 3. It will be uploaded shortly.